Hello everyone. You know the drill here. Leetcode questions mornings, coffee. So let's get started. Let's see. Let's look at some new problems for today. I've been very good today. I've been doing one problem. This week I've been doing one problem a day. The next one here is the convert BST to greater tree. What is a greater tree? Greater tree such that the key of the original BST is changed to the original key plus the sum of all the keys greater than the key in the BST. That's it's kind of confusing. So key plus the sum of the greater, I see. Key plus the sum of the greater keys. So, okay, so because it's this plus everything greater than it. And then in a binary search tree, everything on the right side is greater than it, right? So this one is 6, 7, 8, it's 21. This one is 5, 6, 7, 8, 26. This is 4, 5, 6, 7, 8. Okay. Ooh. That is a hard one. So what's the constraint? My first instinct is to find all the nodes, and then I could add up. So if I DFS through this thing, I could add 1 to 0, add 2 to 1 and 0, add 3 to 2, 1 and 0, but I feel like that's going to be very expensive because I would first need to find it, every single node, add it to every single node before it, which is already n squared. And then I'm also not sure that I could preserve the binary search tree as I go. For example, like if I had found, like for example, if I add 2 to here, that would be 3, and this would be 2, then it's not a binary tree anymore. So I cannot, actually that's not right. That's not the correct answer, because then I can't preserve the invariant, right? So that's actually not the way to go. But normally with these types of questions, what happens is that you have one single key to solve the question, and then once you find that, everything else becomes easy. So with binary trees, what you want to do is you want to simplify it so then you only have a parent node and the tree the trees beyond the trees below it. So if I go to the right first, actually, then I know I would have already seen the maximum, right? So what I'm getting at is that if I am at 5, I should have already seen that I need to add it to 21, because it's the total of this right side. If I'm at 4, I would have already seen 26, which I know that I'm going to add 4 to 26. Yeah, so you're actually going to traverse to the right side instead of to the left, and then you need to keep track of the maximum as you go, and then you add it to its value, to its root value. Okay, I think, yeah, and that would just be DFS complexity, which I think is linear time. And that would be more than fast enough to do this problem, I think. Okay, so I need a tally of the current sum, self.current sum, and then I'm going to go ahead and DFS write root, and then return root, def DFS write root, normal DFS algorithm is if root equals none, return if root dot right, because I want to go right first, then what I want to do then is I just want to go to the right, and then I need to keep a tally of the current sum. So self.csum is equal to the current roots, the node's value at the moment, right? Because if I am at 8, then my current sum is currently 0. Then I need to add 8 to that. Now my current sum is 8. I need to add 7 to that, right? So that's why it's root.val. And then my current sum is 15. I need to add 6 to that. My current sum is 21. I need to add 5 to that, right? Then my current sum is 26. I need to add 4 to that. You get it. And then that would be the root.val self.csum if root.left, normal DFS algorithm here. If you don't know what DFS is, I'll look it up. This is pretty standard. I believe that is it. Let's test our answer. Oh, exactly 2 arguments. What? DFS right takes exactly 1 argument, 2 given. Ooh. Python is kind of interesting that you have to put the self as part of the argument for a class. What is it now? Solution has no attribute DFS left. DFS right. Ha. 30, 36, 21, 36, 35, 26, 15, 3 nulls, 133, 3 nulls, and then 8. That looks perfect. I think this problem isn't too hard. What could potentially make it hard, this is nice. So what could potentially make it hard is the fact that we normally think of DFS as going to the left first because that's how we read. But I noticed that some of these problems you kind of have to think outside the box in order to do it. And I've learned that from other problems. So so hopefully that kind of gives you some insight on how to do some problem solving with these types of questions. Next time.